I'm going to be doing a problem from Khan Academy under the section normal distribution area above or below a point. If you pause the problem and you read it, you'll see that we're trying to find the area above a point, and I'll explain basically what that means in a second. But a set of middle school students' heights are normally distributed with a mean of 150 centimeters and a standard deviation of 20 centimeters. Uma is a middle school student with a height of 165 centimeters. What proportion of student heights are higher than Uma's height? So they're also basically talking about the proportion or the area. That's what we're trying to find, and I'll visualize that real quick for you. So I'm gonna do import. Actually, I'll start with from SciPy. The day I can learn how to spell. Import stats, and then we're gonna import matplotlib dot pyplot as plt, and then import numpy as np. So we're importing, these are basically libraries. You can think of libraries filled with functions that are already written for us that we could just call and use. They're pre-written functions. SciPy is basically a kind of like a stat library, and I'm importing stats, right? And that's how we're gonna get our normal distribution. Matplotlib is a visualization library. That's how I'm going to visualize the distribution for you. And NumPy is it kind of builds on like arrays, like numbers, and that's how I'm going to get like my x values, and I'll show you how that's done in a second. So we'll start with np.linspace. So linspace is a function from NumPy that lets you set a domain. So you start off with like a certain point. For my case, or for this case, we know that the main is 150, so I kind of want to do maybe 140, start at 140, end at 160, and have like 1,000 values. And if I run that, that's going to give me an array that starts at 140, ends at 160, and has 1,000 values in between. So as you can see, if we scroll all the way up, it starts at 140 over here, and if we scroll all the way down, it stops at 160, and it has 1,000 values in between. That's what it does. And you can say 10, and it'll give you 10 values in between, right? But we want 1,000 values because we want to, the more data values we have, the more normally distributed it is. That's large counts. But yeah, so basically we're gonna set that equal to our x values because we want to calculate the area for each for each value respectively. So then our y values is going to be equal to stats.norm. So norm is a function from stats, and we're going to do norm.pdf because we're trying to find the probability density function. So we're trying to find the density of each of the x values, right? So we're going to pass the x values. So we're trying to find the density of each of the x values, and with the location, so location stands for mean, so they say a mean of 150 centimeters, and the standard deviation, so in Python that's scale of 20. So to remember it, scale is the only one that starts with s, so that could be standard deviation, and then obviously location would be whatever is left, which is the mean. Okay, and now to if you run this, it's not going to give you anything because you set it as values now, as variables. But now I'm going to plot. I'm going to do plt.plot, and plt, that's matplotlib. We just imported it as plt, so we don't have to write matplotlib.pyplot.plot. That's a lot. That's a lot. So we're going to do .plot, and we're going to plot our x values, and we're going to plot our y values, and let's see what that looks like. That's really bad. Okay, 150 and 165. Did we have 165? No, yeah, it's a standard deviation of 20. Maybe if we do 100 values? 10,000? 140, 150? More than 10,000? 50? Why is it gonna change? 140 to 160. I guess that's not really normally distributed. 120 to 180. 100 to 180. 200. Basically whenever you feel like it looks normal to you. So normal basically means symmetrical. So now it looks normally distributed, but generally it is normally distributed, even if you don't see it on the graph, because it literally is telling you it's normally distributed. So this is basically what we're looking at. Yeah, that makes much more sense. And then what were we gonna say? Oh yeah, so let me add a title for the graph. So this is basically a normal distribution with, let me search up the mu symbol. That's not how you spell symbol, but okay. I mean, it is. I mean, I spelled it wrong, but whatever. And then let's look up sigma symbol. So with a mu, which is mean, of 150, and a sigma, where's the lower, this one, a sigma of, what is it, 20 centimeters? 20 centimeters, and let's put this in context, 150 centimeters. Run that, and let's do x label, which is our x-axis label, and we're going to call it height in centimeters. And then we're going to do our y label, and we're going to call it basically density, the density or the probability of each height, you know. We could also call it probability, so the probability for each height, well, not probability, because then, yeah, let me call it density. Okay, density, okay. Or you could call it area, well, not really, that's not the area. The area is the area inside the curve, yeah, okay. So this is our graph, basically. I'm going to save the image, I'm just going to show you basically what it looks like. I'm going to call norm dist, and I'm going to save it in, that's too much, pictures, documents. Let me save it in documents because I have nothing there. Okay, let me open this up. Go to images, my device, go to documents, and just upload this. Okay, so real quick, let me just take my tablet out. Okay, so how do I lock it? Lock, right there. So basically, they're asking for, what are they asking for? I forgot. Okay, 1 second. Okay, they're asking, what proportion of student heights are higher than Uma's height? So I guess we could say student heights for the X label. So Uma, they said she was 160, he or she, I don't know. They didn't specify the gender. Where is 165? Yeah, 165 centimeters. Okay, so 165 is about, now I can't see my mouse. 165 is about like right here. So basically they want this area inside the curve. They want, that's the area or the proportion of students whose height is higher than Uma's height, which is 165 centimeters, right? That's Uma's height. So how do we get this? Well, there's this function. It's called normalcdf. So in your calculator, in your TI-84, you can put, I think if you do TI-84, TI-83, whatever, you do second, and then you go vars, and then you click on 2, and then you have your normalcdf, and it's going to ask you for your lower, your upper. Don't even ask me how I memorized this. I've just done it countless of times. It has become very tedious. Okay, lower, it's going to ask you for your upper bound. I think it asks you for your mean, your sigma, and then there's a paste option that when you hover over it, it becomes black. So in other words, it's going to look like this. So normalcdf, so your lower bound, upper bound, mu, which is your mean, and sigma, which is your standard deviation. So lower bound is basically where you start. So you start here at 165. So it's going to be 165. you end never, because it keeps on going. This line never touches the x-axis, therefore it never becomes 0. Therefore, it just keeps on going forever. So you use a big number to represent infinity because there is no infinity in your calculator. So you do 1e99. Well, I do 1e99. Some people do like 9999, but I think 1e99 specifies, infinity. So it's going to be 1e99. And then your mu, what was it? 150. And then your sigma was 20. So 150, 20. And then you just click on paste, right? And you click enter, and it should give you an answer. Now this answer, you're going to actually have to subtract 1 minus that answer, because normal CDF calculates if you have a normal distribution and you have a certain point, like let's say point X, and you tell it to calculate that, no matter what you put, like lower bound or upper bound, it's gonna calculate the area on the left of that point. So you want to do, well actually, it's always going to calculate the area left on that point, but then you do specify where you want it to be. I think, well, usually you would want to do 1 minus. Hold on. Okay, X point, right? And then it's always going to calculate the area left to that point. So in order to find this area that we want to the right of that point, we need to do 1 minus the area that it calculated for us, which is the green area right here, and that's going to equal your pink area, right? That, oops, nope, wrong color. Hopefully that makes sense. Okay, but that's only if they're asking you for anything that's above, because obviously normal CDF does everything, calculates the area or the proportion that's lower or below a certain point. So if you want something higher, you're just gonna have to do 1 minus that, because obviously that's the opposite, right? Makes sense. So I'm gonna show you how to do that with Python. If I can find my thing. Okay, so let me just have this here on the side. Take this tablet off. Okay, where were we? Okay, so the calculating part. So we're gonna do stats.norm.cdf, right? And this time it's the same format. So lower bound is going to be actually, oh, this is why. I just figured out my problem from yesterday. So, okay, so here's the thing. In your calculator, you do not have to do 1 minus anything. So I have to retrace. I'm sorry because I messed up. You don't have to do 1 minus anything in your calculator because you specified, where is my pen? Oh, I don't have it. Okay, hold on. Oh, this take 5 hours. Okay, because you specified your lower bound, like where you want to start and where you want to end, it's gonna calculate the probability in that way, which made sense. That's why I was like, wait. I messed up on saying that it doesn't matter, like regardless if you put lower bound or upper bound, that you still have to do 1 minus the area. No, that's not true. Because you did specify the lower bound and upper bound, then that calculates the actual area under the curve within the parameters that you gave it. So it's going to start at 165 and it's going to calculate the area above the curve. So you don't have to do 1 minus that in your calculator. But if you're doing it in Python, the reason why we do have to do 1 minus that area is because they don't ask us for any upper bound or anything. They just tell us, they only allow us 3 parameters. So they allow us for the x value, whatever value that we want to find the area above or under it. and then they ask us for the mean and the standard deviation. So they only ask us basically for one value. So in this case, that value is 165. The mean, so loc, right, is the mean, stands for mean, is 150, and scale stands for standard deviation is 20, and then you're going to have to do 1 minus that. So you're going to have to do 1 minus that's that norm CDF, and that is going to be your probability for this. So 0.2266 is the probability of the student's heights being greater than Uma's height. And that's the not the probability, the proportion. The proportion of student heights that are higher than Uma's height is 0.2266, right? And you always want to round to 4 decimal places, at least in stats. So let me round 4 decimal places. Now here's a little trick in Python. Stats.norm.sf is a function that calculates, it's basically CDF, but the opposite. So you don't have to do 1 minus anything. So you put your thing, 165, your location, which is 150, your your mean, and then your scale, standard deviation, which is 20, and it's going to give you, when you run, once you round it, let's round it to the 4 decimal places, it should give you the same answer as you would do subtracting 1 minus that, because it basically, they were like, okay, well, subtracting this from 1 every single time is kind of tedious, so might as well just make a function that does that automatically. So SF is basically the opposite of CDF. So this calculates, so CDF in general calculates the proportion or the area of below a point always, but then 1 minus CDF calculates the area, well, it calculates 1 minus the area below a point, which is the same as the area above a point. So, but it calculates the area above a point, or calculates 1 minus area below a point. And then this one is just the opposite of CDF, and the same as 1 minus CDF. So SF is the opposite of CDF, of the CDF function, but it is the same as 1 minus CDF. So it calculates area above a point. Okay, so basically in the function, again, these are pre-written functions. So basically in the function, I imagine that somewhere they're literally just doing 1 minus CDF and then returning, okay, this is your answer. And the only thing that's different is the name. And they just have 1 minus CDF at the end to like say, okay, well, yeah, just give me the area above this point. So, yeah, I remember being confused when I first learned this. I completely forgot. I was like, wait, so where do I put my upper bound or lower bound? And they were like, and then I kind of did research and it was like, oh, I can only put like only one value, and then I'll have to like, use like common sense, because you have a whole. If you have one part of the whole and you're trying to find the other part, just do 1 minus that, right? So you find that. But I guess if you want to find an area above a point, you want to use SF, right? And if you want to put find an area below a point, you want to do CDF. And I think that's it. So let's put that answer in there and hopefully we are right. Did they say 4 decimal places? Yeah. Okay. Great. But yeah, I feel really bad because I did say that, like when I was explaining over here in the whiteboard, like I did say that you have to do 1 minus CDF in your calculator. No, you don't. Please don't. Please disregard that I said that. You only have to do that in Python. In your calculator, if you do normal CDF and you specify your lower and upper bound, it will calculate the proportion, excuse me. I've just got done with probability. The proportion of whatever you're trying to find based on those parameters that you gave it. So there's nothing else to it, okay? So don't you do 1 minus anything. Just use the function as you would in your calculator, but in Python, it's a little different. You do have to do 1 minus the area, or 1 minus whatever you get for your CDF function, and that's going to give you the proportion above a point. But if you're trying to look for proportion below a point, so if they ask, oh, what proportion of students are are lower or have a height that is lower than Uma's height of 165 centimeters, then you would just do CDF and then that would be your answer. But because it's asking for the proportion of students who have a height higher than 165 centimeters, which is Uma's height, then you want to do 1 minus CDF. Or in this case, you could just do SF. But in your calculator, you would just do normal CDF, specify your lower bound, which is 165, specify that you want it to go to infinity. So basically you're saying, hey, I don't want you to calculate this probability, no, not probability, this proportion, or this area, excuse me. I don't want you to calculate this area from below my lower bound, which is 165, but I want you to do it from 165 all the way to infinity, which is 1e99. And then use a mean of 150 and a standard deviation of 20. That's what you're telling it. So it's doing that for you. It's specifying it. So yeah, hopefully that makes sense. Hopefully I didn't confuse you, and my bad for my little mistake later. Anyway, bye. How do I close it? Okay.